to this computer. Today I'm speaking with Mario Zechner again. Mario has been a guest on this podcast before. Please listen to the excellent episode 5 titled The Value of Thinking and Acting Independently to find more about his background. Today we talk about Mario's most recent creation. It's hardware this time. It's an audio player for children. First of all, I love it. I love the player. You added something to one of my favorite product categories. Welcome to the show again, Mario.
Hi.
Cool. Before we jump into the show and tell and the questions, let's talk a bit about well, let me review the three big players on the market. So we just have some context for what market you created that player or where you placed that player into. Okay, let me give some context. If you're a parent, you likely know about the product category of audio players that are specifically made for kids. They're easy to use, hard to break. They're portable, so you can take them on long car rides or flights. They make us provide a large content library, tailored for kids 3 years and up. The heavyweights in this product category are, first of all, it's the Toniebox. It comes from Germany. It's a 12 by 12 by 12 centimeter box. It's padded and contains a speaker. Kids change the content by putting a little figurine on top of it called a Tony. And the controls are 2 ears for volume and tilting the box left or right to skip forward and backward. That was actually the first player we purchased in our family. And I also do remember when my daughter Lynn accidentally cut off the ears and rendered that player dead. So the next player is the Yoto Player. The Yoto Player comes from the UK, and it's a similar size as the Toniebox. It also comes in a mini version that's better for traveling. And kids change the content by sliding in cards. And there are two big knobs in the front. Parents can also use their smartphones to play content on the Yoto Player. And the Yoto Player has a little LED display in the top, in the bottom right corner. And finally, it's a more recent addition. It's the Tiger Box or Tiger Box. It also comes from Germany. It's a similar size as the Toniebox, and it has a very large display. And it works with cards and also with a streaming subscription. And the streaming subscription gives you access to 20,000 titles. Just also nice because it's produced by the company Oettinger, which also owns a lot of content. So kind of a nice business model you must have going there. Okay, so now that we talked about the three big players, please tell me what your player is and how it works.
Okay. It's kind of a mixture between the Toniebox and the Yoda player. It's a self-designed little gadget that kind of looks like a Game Boy, like one of the old Game Boys, but instead of the screen, there's a big, I think it's a 4-inch player, 6 centimeter, 7.5 centimeter speaker instead of the screen, and at the bottom there's buttons to change the volume. Well, or rather, it's a potentiometer to change the volume, so a little knob you can turn, and 2 buttons to skip forward and backward, and that's it basically. At the top, there's a slot, also kind of like the original Game Boy, where you can put in a cartridge, and the cartridge contains the audio play. So my kid likes listening to, I don't know, In a Land Before Time, audiobooks, and other things like that. And basically, each cartridge is either a full audiobook or a collection of songs or whatever I really want to put on a cartridge. So that's like the overall bird's eye view of the whole thing. Internally, it shares some similarities with the Toniebox. It's using a microprocessor from Espressif called ESP32. Then there's a audio amplifier, which is just an integrated circuit that's connected up to the ESP,
So we're looking at
which
this here
receives.
now. So
Yes,
the expressive is the thing in the right corner here.
Yeah, exactly. The audio amp is the blue one.
Uh-huh.
And below that, there is a sort of motherboard where both of these modules plug in,
Hmm.
which also has the buttons and the meter soldered to it. Everything in this thing is self-designed, including the PCB for the ESP32 with power management and so on and so forth. The motherboard, the only thing I didn't design myself is the little audio amp, the blue PCB you see in a picture. I was just too lazy to also design that myself. But I'm very proud of myself for having designed the
Yeah.
ESP32 board with the power management, which allows the thing to be powered both by USB-C or
Uh-huh.
by a LiPo battery, or in its latest iteration by three AAA batteries to make it the least dangerous of all of these
Okay.
devices.
Well, before we go into the design, or before we go into details in the design, since you created this all from the ground up, um, what motivated you to make your own audio player? Like, what was the
so,
cause?
so my boy got his Toniebox at a very early age, I think about
Yeah.
when he was 1 year and a half or something like that. And I hated it. First of all, the speaker quality is really poor
Uh-huh.
for a device that I think now it costs 80 euros. Back then it was, I think, a little bit more expensive. Anyways, for a device with that price tag, I expect better sound. It's okay to have a mono speaker, although I wished there was a stereo option,
Hmm.
or
Hmm.
that there were players with stereo, because for music it does make a difference. But regardless, for such a more or less expensive device, I expect better audio quality. So one goal was to improve on that, and I think I've succeeded. Even though I'm not an audio engineer, I have no idea how this works. I just plugged in a speaker I think has good properties. The second problem with the Tonybox, you said tilting would skip forward and backward.
Yeah, controlling,
Uh,
yeah.
yeah, so there's skip between chapters and skip within a chapter, like skip forward by a couple of seconds and so on.
Hmm.
Neither of those two control methods, because there's two control methods actually. So skipping by tilting or skipping by smacking the thing left or right. And honestly, even as an adult, I was never able to get the smacking working. So
Yeah,
skipping a
yeah.
whole chapter just does not work. And that's frustrating, both for me and for the little one,
Hmm. Hmm.
because once the little one has listened to an entire audiobook with multiple chapters, like In a Land Before Time, there might be a song which is its own chapter. And sometimes he just wants to listen to the song. So he wants to skip forward past
Hmm.
all the storytelling and just listen to the song. And on the Tony box, he couldn't do that. So controls were really terrible with Tony box, in my opinion. So I wanted to change that to make it child compatible. um, and the third big problem is content, actually.
Hmm.
Tony, I don't know what the company name actually is. I guess it's Tony. Don't know. Anyways, the company that is selling the Tony box has a lot of content agreements with a bunch of big and small publishers. So you can find a lot of things, but it's all very expensive.
Hmm.
The
Hmm.
little figurines aren't super cheap for what they actually are. Um, and there's also a lot of content you just simply cannot find, which he really likes. So I wanted to have an option where I'm in control of the content, while still having something tactile, like a cartridge, like a Game Boy cartridge, for him to have like a physical connection to each audio play, to each cartridge. So I thought, for me in my youth, the Game Boy cartridges had like their own little soul, and
Yeah.
you associate some kind of feelings or mood with each of the cartridges for the Game Boy. Like Super Mario Land 2 has a special place in my heart, just like Ocarina of Time, Zelda has a special
Uh-huh.
place in my heart. And just looking at
Guess
those
who's playing
cartridges,
that right now
yeah.
with my son?
Yeah, so I think like the Yoda thing that has
Hmm.
little credit card like
Uh-huh.
RFID
Yeah.
tags.
Yep.
I think that is kind of fine, but if you plug it in, it actually disappears into the Yoda player, so you don't see the full cover anymore.
Hmm.
In my case, if you slide in the cartridge, the cover is actually fully visible, so it sticks
Hmm.
out at the top.
Yep. Yep.
Um, and that makes a big difference because he can look at the thing while he's listening
Uh-huh.
to it, and that helps associating whatever mood he's in or whatever situation he's in, listening to the thing. He might listen at it at home in the kitchen or outdoors, or while we are driving with the car, or while he's being driven around in his little buggy. So I wanted that to be always visible entirely to him, just like a Tony figure is visible. The problem with that is, in case of the Tonys, that those Tonys fall off real easily. Like, just, I don't know, maybe not in the car, but if you go by buggy and are in less even terrain, or if it just moves quickly with the thing, the Tony would just fall off the little figurine and playback would stop. In my case, the connections are such that there's just no chance that the cartridge would fall off, irrespective of what it's doing, except for maybe throwing it against the wall. So that was another design constraint I tried to follow. And I also wanted it so that it's very easy to create your own cartridges. Um, so my wife can also create them. So the cartridge consists of a rectangular PCB where there's a SD card connector on it. And the pins of the SD card are essentially just externalized through big pads at the bottom of the PCB. And on top of that PCB, I just screw on a 3D printed cover plus a label, which is basically the cover of the audiobook printed out onto a sticky label that you stick onto the 3D printed
Okay. Okay.
thing.
Okay. Before you go any further, let me just quickly summarize. It's a lot. I know you've been super close with this for a month, right?
Yeah.
But you you saw the limitations of a couple of players in the market because you own at least two of them. You know, the Yoto Mini and the Toniebox, and you think the audio quality wasn't there because the speakers are very tiny that are built in. For example, the Tony, also the Yoto Mini. Then the UX was a problem.
Mm.
Skipping, really hard to learn. Actually, didn't know it exists on the Tonybox. Even
Yeah.
the even the Yoto player is it's kind of, I always get confused which of these knobs is what. Is the left one the volume or is the right
Yeah.
one the volume?
Honestly, I played around with
Why?
the Yoda a little bit, but it made no sense to me as an
Mhm.
adult. So, what is the expectation a child can do with that? It's just, I don't know.
Right. I mean, it looks good. I mean, it's nicely designed, but it's not very usable. I agree. And then the
Yeah.
content. So the content was limited, and
Mhm.
then a visual aspect. You saw that the Yoda player has the card, but when you stick in the card, it conceals more than half of the design of the card,
Yeah.
and you wanted to give it a like a Game Boy retro vibe.
It's not
So
so much about retro, it's more
yeah,
about tactility. And I think
quality.
the
Okay.
electronics designs from back in the days when we were children
Hmm.
were much more tactile. Like, I would have a
Hmm.
cassette recorder, a double deck cassette thing where you can
Hmm.
plug in a cassette on one side and then another cassette on the other side.
Yes.
And you have just a bunch of very obvious buttons that let you
Mhm.
record from one side to the other, or record your own voice and stuff like that. And I really like that kind of design because it's intuitive, it's physical, it's tactile. It doesn't involve any screens. I'm not against screens. I just think for an application like that, you do not need screens. Um, so I wanted to go back to a design that actually makes sense. Um, intuitively, and I think
Mhm.
with what I have, it does make sense. I compare
Yeah.
it to cars that now all opt to have touchscreen interfaces, which is
Mhm.
the stupidest decision design-wise you can have in a
Uh,
car. Um, if you compare that with the old car design dashboards where everything is a little knob, you can turn or push and have like muscle memory to actually hit the thing without
can
taking your
operate in
eyes
the
off the
dark
road.
without light
Yeah.
on.
Yeah,
Hmm.
exactly. So it's kind of like that, you know. I mean, the
So
Tony
okay,
box,
okay, go
Tony
ahead.
box is very close to that. I
Uh-huh.
think it's just that the skipping mechanism is so terrible
Okay.
that I wanted to build something that's just working, like without a lot of effort and this intuitive.
Okay. Cool. So you have your requirements or pain points, and then you start designing your own player. And you tell me, so you I know you as a software person. You you write programs and software systems, compilers. We talked about this in the other podcast. Hardware seems to be a new medium for you. Um, maybe I'm wrong. Correct me.
Oh yeah, totally. Like
Uh,
6 months ago, I could have probably electrocuted myself with a
mhm.
9-volt battery.
So how did you start? Yeah, things you didn't do that. How did you
Yeah.
start out? Like how did you start with the design of your audio player? Like how did you pick, okay, it needs to have these components to do that. And here are my options. How did you, yeah, get an overview and then narrow it down and then wire it up? And which tools did you need in that process? Which tools did you have to acquire? It's a lot. And this question, I know it's multiple questions, but pick the one out that you want to start with.
I'm just gonna start with, hey Mario, you're a software guy. How did you come up with the hardware bits here? So
Yeah.
yes, I'm actually 100% software guy. I had no idea about electronics or anything like that, like 6 months ago, or no, a little more. It's now 9 months ago. I honestly, I just started by buying an Arduino kit, which is a very popular but very not so powerful microcontroller, which essentially lets you connect a bunch of things to it through pins, GPIO, they call it, general purpose IO. So you can either send a signal or you get a signal and read it. And the thing that's reading it is a piece of software that you write for the microcontroller, which is just a tiny little CPU plus a little bit of RAM. And that lets you interact with the physical world by writing a computer program and sending electrical signals through the pins to the outside world, or reading electrical signals in your software running on the little microprocessor. That's how I started, right? And that's usually where people stop. Like you connected an LED to it and you turn it on and off, or you make it turn on and off with a pattern and whatever. And that's about as complicated as most people go. But my motivation for doing electronics was actually, I wanted to build stuff for my boy. I didn't want to buy the crappy, super cheap Chinaware. Nothing against China; they're amazing. They have amazing technology, but most of the crappy toys come from there. So I'm saying Chinaware. Um, I didn't want him
They do it
exposed to
all.
any of that. Yeah,
High end, lower end, and everything in the middle.
yeah. And so I just started learning electronics from the ground up. Like
Hmm.
start with what's voltage, what's current, and so on. And
Hmm.
I actually, most of the first 2 months, I just read a lot of books
Okay.
and found out that most of the books are really terrible.
Hmm.
There's only two books I would recommend. There's Make Electronics by Charles Platt. It's really great. It gives you the basics without microprocessors, just your basic resistors and capacitors and how things fit together and how to calculate electronic networks and so on and so forth. And the other is Electronics for Beginners by Jonathan Bartlett. I actually wrote that guy because I was so impressed by this book. It was so well written. And it had it's basically a book written by a software developer for other software developers who want to get into electronics.
Okay.
So that was a big help. Um, and he's also an A-Press author. And like 15 years ago, I also wrote a book for A-Press. So there was some connection there as well. So I wrote him and he was really happy getting that feedback. Yeah, anyway, so those two books were great. I also tried things like Art of Electronics, which is basically an undergraduate book for university. It's totally useless for somebody who wants to do the thing I did here.
Hmm.
And there's a bunch of other highly recommended books, which I did not find very interesting. So once I got the basics, like how do I power on an LED? How do I read a button state in software that's basically presented to me as a voltage? Stuff like that, the super basics. Once I got that down with something called a breadboard, which is just a little board with a lot of holes in it that are electrically connected, and you can wire up your microcontroller to it and a bunch of external components.
So you do talk about software here in the context of electronics. Like what
Yeah.
programming language do you use for this
Um,
microcontroller?
in this case, C++.
Okay. So you write it on your computer and then you transfer it to the microcontroller. Or do you
Yeah,
simulate
exactly.
it on a computer or how does it work?
So
I have no clue.
yeah, yeah. Basically,
Fascinating.
so the little microprocessor, the ESP32S3,
Mhm.
has built-in USB support. If
So
you
that's this
connect,
part here. Is it true?
yes, exactly.
Okay.
But this is a cover. and beneath that there are a couple of chips actually, but you can think of it as the microcontroller, right? And you see those little pins around it. There's 45 pins or so that you can expose to the outside
So these
world.
guys here on the outside?
Exactly. These guys on the outside, they are connected to either the components you see on the right of it, which is power management and other stuff.
These components here?
Yeah, exactly. Or to the little pins on the side of the board, the rows.
These guys here.
Yeah, exactly. These guys here. And these guys here are basically just connected to one of the pins on the microprocessor. So think of it like there's a wire between one pin on the microprocessor and one pin on the board. And those pins then are connected to the other bits you see in the image. Like you see the blue thing that is connected through
like this here?
Yeah, exactly. There are 6 pins at the top, and those are connected to 4 pins of the microprocessor and 2 pins for power.
Okay.
Yeah, exactly. And then you have those wires you see on the left going up to the connectors. To the
these guys here?
Yeah, exactly.
Oh, the whole thing here. Okay, got it.
Yes, the whole thing here is also connections. Each connection is basically a wire going to a pin, and the pin connects to a pin on the microcontroller.
Oh.
And those are actually the SD card signals. Like if you buy an SD card, it has a bunch of pins, and these are exactly the same things. Like I just took a tiny micro SD card, made the pins bigger, so I can slot it in. That's what the cartridge is, basically one big SD card. And here I just read those SD card pin signals directly into the microcontroller, so I can read and write files. And it's really not complicated if you get used to it. Just like building simple software projects is not complicated for somebody who's experienced in software. Right? Like you can probably write a little CRUD application in no time. And it's kind of like that. You just need to learn the trades, the tools of the trade, so to speak, which is PCB design software. Those are called EDA application, electronic design applications. There's a bunch of them. I don't know. I use Easy EDA. It's a Chinese thing because it directly connects to the PCB manufacturer in China, which makes everything very simple. But most people don't use that. Most people use an open source program, the name of which I've forgotten. Then there's from Autodesk, Eagle, and so on. They all basically do the same. You first design the schematics, that is like a logical network of components and wirings between components. Like the microprocessor would be in there as a logical component that has pins that you then can wire up to other components in the electric network. And once you have that done, you go to PCB layout. That means now you take your logical schematic and make it a physical thing. So you define the dimensions and outline of the PCB. And then within that, you drop in the so-called footprints. So you can think of each of these little components, like the chip or the resistors or capacitors, has connections, which you can solder onto a PCB. So if I have like a resistor has 2 pads on it with a dimension and distance to each other, and that is the footprint, like the parts of the resistor that you can solder to. And you just put that same thing on the PCB. So you have 2 tiny little pads on the PCB, and you can put a resistor on top of it and solder that to the PCB. So PCB design or layout is basically just distributing your components over the area of the PCB and wiring things.
Interesting. Okay.
That's all it is. And the EDA, the electronic design application, helps you keep track of things because it would be very hard to do this manually. So it will show you a net of connections between everything, how you design it schematically. So you don't lose track of where you need to put what's called a trace. Think of a trace as a wire going through the PCB from one end to another end, right? So you basically just lay out your components physically and then wire them up just on a computer instead of in real life.
Okay, so does that give you iteration speed? Like, can you do tests with that software?
No, nothing. Not with my software. There's simulations, but It's honestly, I don't think there's some for electromagnetic interference stuff. You can calculate how bad your signals shielding works or not, and so on and so forth. But like fully simulating a PCB design, I don't think there exists anything like that. So what you basically do is you read for each component, you read what's called a data sheet. It's like the documentation of the
Hmm.
thing, right? Forget an integrated circuit, an IC. It comes with a data sheet that tells me what are the inputs and outputs, what other components do I need next to it, connected to which pins, so it works, like capacitors and stuff like that. It tells me maximum and minimum electronic parameters, electrical parameters, and stuff like that, so I don't blow it up by accident. So if you look at that green board here, there's about 32 components on that, and each of that has a data sheet telling me how it works, what the inputs and outputs are. And then it's basically just like writing software where you have libraries and they have an API and the documentation for the API. And if you build an application in software, you take a bunch of libraries and glue them together for making a whole application, right? And this is very similar, except there is no compile, run, and debug thing because one iteration here takes a week.
Yeah.
So you design the whole PCB, you send it off to a manufacturer in China, and a week later you get a board, and then you assemble it, solder it, and then hope that you didn't make an error. Because if you did, you have to redesign the thing, send the new design, wait for another week.
Which brings me to the next question. Tell me about the mistakes you made in this process. Did you make any? And
Yeah. So honestly, all my boards just worked, which is crazy. Before this project, I did another project, a Halloween prop for the
Mhm,
children in
mhm.
our hood, which was a cauldron, like a witch's cauldron, with an LED strip at the top, where each child could pick its own color, and it would glow mysteriously in the
Yeah,
dark,
yeah.
and a speaker and an ultrasonic sensor. And if anyone, so it was supposed to be used for getting candy from people, right? Like trick or treating around the neighborhoods. You have your cauldron and you run around with that as a kid, and you ring the doorbell and say trick or treat, and then they put in some candy into your cauldron. And as soon as the hand goes in, the cauldron will scream at the person or say something. And each kid was allowed to record their own like sound effects
Mhm,
and
mhm,
whatever they
mhm.
wanted. And every time somebody puts the hand in, the cauldron lights up menacingly and also plays back one of the pre-recorded children's sounds that they recorded. So that was my first project, and that had a lot of problems. So I basically had to iterate on that like 4 or 5 times. But the good part about that was that I gotten used to the idea that my design has to be perfect before I send it off for manufacturing. So when I do software, I basically do good old compile, run, debug loop, right? Here, I actually take a lot more time once I'm done with one iteration to think through it, go through all the data sheets again, check every connection I made, check the data sheet values, whether they fit, and so on and so forth. And then I sleep over it for a day and then do it again. And after 2 or 3 of those check loops, which are only like a mental thing and not a physical thing, once I'm pretty sure I checked all the things, I send it off and
Okay,
hope for
so
the
you
best.
think it through at least twice.
At least twice, yeah.
How did AI tools help you in this? Getting familiar with
Not at
electronics
all.
and not at
They're
all.
totally fucking
Okay,
useless for this. Yes.
interesting. What did you
No, if you
try?
use those, all of them, especially in the beginning, like when I started with
Yeah,
the most basic shit, they were super useless, like
yeah.
absolutely
Like, what did
fantastically
you
useless.
ask, for example? Do you remember like questions you asked in the beginning?
Oh yeah. In the beginning, I would ask about specific properties of specific components,
Uh-huh.
and how they could fit together. That was just terrible. I would ask for producing simple schematics. There's like a markup language, I forgot its name, that you can use to describe schematics instead of graphically representing them, right? Like think of how you would encode a graph
Yeah,
in
yeah.
plain text,
Mhm,
something
mhm.
like that, right? And I would ask it to produce something like that, or just an ASCII schematic, and it's totally fucking useless. And also, like if you do anything with high voltage, high current, I guarantee you it will tell you the wrong thing, and you will get hurt. It's really, really bad. And I tried mostly GPT 4.0, at that point there wasn't an O1 or O3, but they aren't any better. I think I tried Gemini just for shits and giggles because it was really bad back then. Claude I tried.
Yeah.
Claude was pretty okay at that. Like I wouldn't trust it at all with anything, but
It,
comparatively it was better.
at that point, did you only ask questions and relied on whatever the model state was and had learned, or did you supply any?
Oh yeah, no, I
Uh,
would supply data sheets and
okay, you
all the
did.
information it needs, and I'm very
Okay.
well aware of context
Yeah.
limitations
Okay.
and recall and blah blah. So I know how to deal with LLMs, right? They are also part of
Yeah.
my day-to-day job.
Yeah.
But in this area, they were completely useless, absolutely useless.
Interesting. Okay, so in terms of um, physical tools, which physical tools did you acquire to create this audio player?
Okay, so the case is actually 3D printed. I
Uh-huh.
designed that as well in something called Fusion 3D, which is a
Yeah.
CAD CAD program. So I need a 3D printer, and I got a Bamboo Labs X1
Uh-huh.
Carbon,
Nice.
which is like the iPhone of 3D printers, but it totally pays off. I had a Prusa before, which was always a pain to set up and configure and so on. And the Bamboo Labs is just plug and play, which is exactly what I want at my
Mhm.
age. I got an industrial grade fume extractor because I'm soldering at home and I don't want to kind of have any bad allergens or toxins roaming around in our flat. So I got that, which cost about 600 euros or so. It's really good. Like it's actually a HEPA filter. Most of the hobbyist grade extractors you get are basically just a fan with
Yeah.
active coal filter, and that's not
How
going to
does that
help with
work?
anything.
How does it? Do you point it to the area where you're working, or is this something
Yeah.
bigger in the
Well,
room?
I have like a Doc Ock from
Ah.
Spider-Man kind of arm thing, which I can move around on my desk.
Yeah. Yeah.
And yeah, it's just a suction kind of thing that I can position in my work area to point at the place where I'm soldering to
Hmm.
actually suck off all the fumes. It works amazingly well, and it's just actually an industrial grade HEPA filter. So I'm very certain that 99.99 of all the toxic shit is getting filtered out. So that's important safety stuff. Then I got a soldering station on an
Is it this one
erga.
here, or
That's a hot gun, hot air
okay?
gun.
On the right, it's the hot gun. Okay. Okay.
Yeah, and on the left, it's the
Is it for
soldering
gluing
station.
or what is?
No.
No.
So depending on how you want to solder something or have to solder something, you can sometimes not use a soldering iron, especially if you want to desolder like a little chip from a PCB. You usually cannot heat it up enough everywhere at the same time so that the solder is not hard anymore. So you can't get a chip off a PCB by just using a solder iron. And the heat gun has the benefit that it can actually heat up a big area in one go at the same time. So all the solder beneath a chip gets what's the English term? Forgot it. Weich.
It melts or it gets
Yeah,
soft.
yeah, exactly. Yeah, exactly. All the solder beneath the chip actually melts and you can take
Yeah.
off the chip. So that's what a hot air gun is for. Um, yeah, anyways, but you need a solder station. I
Huh?
actually have a bunch of them. I have one at the office. I have a cheaper one at the office because for the cauldron project for Halloween, I had another
Yeah.
dad help me assemble like 10 of those cauldrons. So we had two stations. And the second station I have at the office is actually a super cheap one from
Hmm.
Amazon, which costs like $60. But I actually
Hmm.
prefer using it because
Hmm.
it's
Interesting.
kind of better. But I'm
What's
also
that?
happy with this.
Oh,
That's the
what's that?
soldering iron.
Oh, that's a sword. It's hard to see in that. Oh, there we go. Oh, yeah, there we go. Okay.
So yeah, just looks like a
Uh,
pen with a wire attached to it.
is that something you enjoy? Like soldering? Is this
Yes,
like?
it's super zen, man. Like especially, so there's different sizes at which you can solder. Like most people, hobbyists would solder through-hole components that are really bulky and big, and it's very easy to solder them because you can get to each of the pins or pads that you need to solder
Mhm.
very easily. I'm now at like listeners who know electronics will maybe laugh, but I'm now at 0603 and 0402, which is below 1 millimeter components. So I hand solder those because it's just so relaxing. So I also have a microscope, a digital one, and a lens,
Okay.
an LED magnifier lens,
Okay.
to work on really, really tiny stuff below 1 millimeter in size. That's essential for me because my eyesight isn't as good as it used to be. So those are the basic things. So fume extractors, soldering station, hot air gun, magnifier, and a good silicon mat. So there's no burning stuff on my desk. Um, then I have some isopropanol for cleaning stuff. And then materials like wires, soldering, solder, solder paste, a little heat plate where I can put a PCB on, spread solder on the PCB, and then just drop the components, and they will melt into the solder. So I don't have to use a soldering iron. Um, yeah, and a metric ton of components that I need to populate the PCB with.
How did you approach the acquisition of all these individual tools and resources? I mean, it's a bunch, right? How did you select? Did you always get
Um,
the best, the cheapest, or something in the middle, or just random?
No, so it was an iterative process because as my projects became more complex, I needed additional tools. So I would
Yeah.
buy whatever I needed for the next project. And in terms of what I pick, I had a bunch of recommendations for the basics, like the soldering station, the hot air gun. The fume extractor I found online with good reviews. The microscope is pretty much the standard hobbyist microscope that you buy if you have money. Um, and the components, they don't matter so much. The only thing that's really important is which microcontroller you pick, because based on that you win or lose functionality. Like DSP 32 is my preferred microcontroller because it also supports Bluetooth and Wi-Fi. So I also can do connectivity stuff. And it's super fast. I also ported Doom over to it. So that was one of my first more complex projects where I
So
wire up
hold
a
on. Well,
screen.
what does it mean? So yeah, you ported Doom over to that. Did you attach a screen? Like,
Yeah,
how can
I
I
attached I
measure
attached the
that?
screen
Hmm.
and I the breadboard you see in the picture that you have
Yeah.
open there,
Oops,
the white
sorry.
thing.
This
Um,
one? Okay. Lower
yeah,
right corner.
exactly. So I
Uh-huh.
put a bunch of buttons on that and wired those up to the microcontroller, and then I also wired up a screen. I
Uh-huh.
bought like 100 screens over my first 4 months because I wanted to build a Gameboy-like device, and for that I need a
Mm.
screen. So I needed to learn how those screens work, how I can write software that's actually fast enough on such a punny device so it can refresh the screen at 60 frames per second and all of that. It was super because it reminded me of my DOS game programming days because it's very similar. You basically have a memory area you write your pixel data to, and then you tell the hardware, okay, and now send that over to the display through the wire using this kind of protocol, and make that as fast as possible. So I wrote a little library actually for all my little things that I need, like for sound processing and for rendering and for input and output for SD cards and stuff. It's all open source. um,
Thank you.
so, so I built up a framework like libjx just for microelectronics, um, to make every process iteratively easier. And the same is true for the PCB and schematic designs. Like the power management I now have, I can take that part and put it on a new PCB, like a building block, because I know it works and I know how it operates, and it's exactly what I need.
Do you think this happens? I mean, this is of course. Do you think you're a rare kind that you cross over from software to electronics, or does it happen a ton?
I'm not sure it happens a ton, but it is a thing as far as I understood. Like my best friend Nate also had a similar path. Like he actually did some electronics in high school, but he then wasn't that interested because that's just have some LEDs blink and stuff. Then he became a programmer, and a couple of years into his programming professional career thing, he started tinkering again with electronics and taught himself all the things himself as well.
Mm.
Um, and I know a lot of other people who are basically software engineers by trade, but also dabble in electronics. So it's a thing.
Okay, well, you might have already told me that, but what was the most fun thing about making the player?
The most fun thing. On the hardware side, the mechanism that actually powers on and off the device, because it's like actual duct tape engineering. If you look at this picture that you have here, so if you insert a cartridge at the top, right, that's when you want the device to turn on and draw power from the battery. So I could have an explicit button that the boy has to move around to turn the device on or off. Or I could just make it automatic. If he plugs in a cartridge, I know he wants to hear a song
Yeah.
or an audiobook. So I wanted a mechanism that would basically connect the battery to the system once a cartridge is in. And that's actually the design principle I used here. You see a little rod in the red. There's two red parts. A second image top in the middle.
Okay.
Second image.
Yeah.
And there's the battery. Yeah, exactly. There's the battery, and below the battery, there's a little switch. You see that? It has, yeah, this one. This is a switch. You see it has a little arm, like you drew over the arm.
Oh, hold
It's
on.
basically...
Let me zoom in a little bit more.
Yeah,
Okay.
zoom in.
Let's see.
I forgot what the name of the type of switch is, but it's a very common switch.
This one here.
See,
Wow.
Yeah, exactly. And at the top, below it, there's a tiny little gray thing you might see.
This
super
one here.
tiny. No. Follow the little metal arm.
Follow the little metal arm. Which direction?
This direction up, and here there's the little button. And if the little metal arm gets pushed down, the little button gets pressed.
Oh, wow.
And once the little button gets pressed, the cable that's connected to the first pin at the top and the cable connected to the middle, they are now forming a closed circuit.
Beautiful.
And you can follow that one wire, and it goes to the battery. And the other wire coming out of the switch goes to the board. So if that button is not pressed, if that lever is not down, there's no connection between the battery and the board and the rest of the system. And the way the little lever is pulled down is there's a little rod. You see that?
Is this here?
Yes, exactly.
Oh, beautiful. Wow. This is amazing.
So
the cartridge comes in here.
The cartridge comes in here, and it just pushes the rod down 2 millimeters.
Oh, wow.
And then it closes the circuit between the battery and the rest of the system. It's super dumb and super like the lo-fi implementation of this, but it works. And it's raw. I can sleep. And I can sleep with good conscience because I know my boy can't burn up this thing by forgetting to turn it off or whatever. As soon as the cartridge is out, and you always take it out, or otherwise it would keep playing. There's no electrical connection between the battery and the rest of the system anymore. So it's super safe. There's nothing can happen.
Oh, wow. Okay. So,
yeah.
Go ahead.
So that was a fun physical design challenge. Like, and you see there's a bit of duct tape on the rod.
That's a great answer.
Because
duct tape is where on the rod?
The yellow thing.
Let me zoom in again. This
is just duct tape. So I get the physical distances just right that it would make a click and actually push the button down. It's hard to design this in 3D for 3D printing.
Yeah.
But I got it very close, I have to say, just in the CAD, in the CAD program. I just had to nudge it a little bit because of imprecisions during printing and so on.
I mean, it's so impressive and so fascinating. And this is
it's super stupid, man.
Is this rod here plastic, or is it?
Yeah, this is also 3D printed.
Okay.
Everything you see here is 3D printed. I designed each individual piece of this in a 3D CAD program. And the other thing I'm very proud of and had a lot of fun with is if you look at the connector for the cartridge, it's on the other side.
Hold on.
Yep, scroll up. You see those? Yeah, exactly. In the other picture, you see it better to the left. The other picture to the left. So, the cartridge itself is basically a big SD card. And at the bottom of that SD cartridge, there are pads, like big pads, right? And each pad is basically just a connection to one of the pins of the SD card that's inside of the cartridge. I wanted this to be big and sturdy, so I have an easy time constructing a cartridge insertion and holding mechanism that would both hold the cartridge in place really strongly so it doesn't fall off, but also make electrical connection to each of the pins on the SD card inside the cartridge, right? So I've wondered, what is the most sturdiest, cheapest lo-fi solution where I can make both an electrical connection between each pin on the SD card that's exposed on the cartridge at the bottom. Wait, let me show you a cartridge. Look, this is the cartridge.
Yep.
And
Yep.
there is
Yep.
nine pads at the bottom, which are just copper pads, about 5 by 9 millimeters each. And you can put that, if you look at this, you see
I see.
the
Yes.
this is basically just the connection goes like this. Each pad goes on one of those springs.
Yep.
And those springs are actually battery springs. They are not meant to be used for signal transfer, but since they are electrically conductive, I can use them
So
to.
you needed that pressure to secure it.
Yeah, exactly.
Ah,
And
beautiful.
those springs they are springs, so they kind of push back if you push them down. And since they can push batteries in real hard if you make the distances just right enough for a battery. You know battery inserts, right?
Yeah.
You have a feather on one end and one of these on the other end. And if you get the distances just right, the battery will be impossible to take out by just moving the thing around. And I wanted to have the exact same thing here for the cartridges. And so I took just battery strings and made them both the holding down mechanism for the cartridge, as well as the signal connections for the SD card pins. So they are dual purpose. It took me like 4 iterations to come up with this. Before that, I had something like the Game Boy had, like I forgot what it's called, gold fingers plus a socket and so, and it was super hard to insert and get right and stuff. And eventually I just gave up and thought, fuck it. Oh yeah, I also had one with pogo pins, which was a complete disaster. I went through a bunch of high-tech solutions, and then I just said, fuck it, I'm going to use battery spring holder things and used it for both holding down the cartridge and for reading the signals from the SD card.
Beautiful. I noticed when I was looking at your creation, when you put in a cartridge, it's quite high.
Yep.
How does that turn out in practice, in usage? And have you thought about other design solutions for that? You know, like angling that cartridge insert differently.
It's not been a problem. Like he can hold this like a Game Boy, and it doesn't fall out. So he's careful with the device. He's not throwing it around, but he also doesn't throw around the Toniebox, even though it has cushion and all of that stuff. So I think for a kid that is not as patient with the device, it would be a problem. It's definitely an Sollbruchstelle, so a place where things can break. But for him, it's not a problem. So I never thought about redesigning this to make this different kind of thing.
It's nice because you can really show the entire front, which has the graphics on it, right?
Exactly, yeah.
Okay, cool. You still have some time to go?
Sure.
Cool. This is fun. All right. So we talked about the components a little bit. Where did you source all of them from China, or do some components also come from different countries?
So the PCBs I designed, I had to send off to a manufacturer. The board you see here is actually from Germany.
Yeah.
Eislinger is the company that does PCBs. Like you as a hobbyist can actually send in layouts and have them printed.
What does it cost? Like just a rough idea.
So Eislinger is quite expensive. I think it's like €5 per board.
Okay.
And with JLC PCB, which is my go-to Chinese manufacturer, I pay €5 for 15 boards or so.
Okay, well.
But you also pay import tax and a bunch of other, like transportation is more expensive because it has to go through international flight and so on. But even then, the Chinese manufacturers are just so much cheaper. And the problem is that the European manufacturers aren't as advanced. Like I as a hobbyist, can actually see the difference in quality, and the German one is worse than the Chinese one, like significantly worse. And the Chinese manufacturers, I mean, they have perfected this.
Can you qualify that? What worse means in this context?
tolerances, how small I can make things,
Mhm.
like traces, how close they can be together. The cutting of the boards, how precise that is. Like the German board actually has like super rough edges and isn't as precise. Like there's a little knob standing out there for like half a millimeter or millimeter, and that can actually make a big difference if you have a hole like a USB-C connector that needs to fit perfectly, right? And if your board isn't cut perfectly, then it won't fit. And then there's finishing materials, and all of that stuff is considerably worse. It doesn't look as shiny and nice. And they don't support non-rectangular layouts, which I sometimes need if something needs to fit in a non-rectangular area.
Mhm. Mhm. Mhm.
Yeah, and it's just overall a lot cheaper, even though I get more product and it has to be shipped from China.
Ah, fascinating. What about the speaker? That
Yeah,
from
that's the
Germany?
only thing I didn't. Yeah, exactly. I'm actually not sure if Isaton is a German company. I think it is. Um, yeah, that's the one of the two components that I did not make myself for obvious reasons because I have no idea how to construct a speaker. And I researched that speaker, and funnily enough, it was recommended as a replacement speaker for the Toniebox. It actually fits inside the Toniebox. And I
Wow.
also have to say the Toniebox internals are super well designed. Like I took ours apart just to get some inspiration. Turns
Mhm.
out they
Mhm.
also use the same microcontroller as I do, the ESP32, at least in the later Toniebox iterations. And the internals are just super
Wait,
great.
hold on.
Like,
This is interesting. Did you open that before you bought your or decided on your microcontroller or afterwards? And,
oh, way afterwards. Yeah, no,
oh,
no. I already had Doom going on my thingy, so
you have a
I
smile on
was
your
happy.
face?
Say again.
Did you have a smile on your face when you saw that they used the same one as you picked?
Yeah, I actually did have a smile on my face. It's a super versatile chip. Like it's
Okay.
super cheap and really great, and comes in different configurations depending on the use case, and it's really good. Yeah, no, and the whole mechanical design of the Tonybox internally is also super, really good. Like really, really good. My thing is like not even a thousandth of the brilliance of the Tonybox design. So, but it works.
Okay, so how did your son react to the audio player when you first showed it to him?
He loved it immediately because I put one of his most beloved audiobooks on the first cartridge, which we couldn't get on the Tony. At
Mhm.
least no official figurine. There's custom Tonys where you can upload MP3s onto a
Mhm. Mhm.
Tony,
Mhm. Mhm.
but then you have the same looking Tony for different audiobooks, and that's nah. Yeah, so the Lenny Hunter thing, that's the first cartridge I made him, and also In a Land Before Time, which are things that we listen to, say, while brushing his teeth through YouTube Music or Spotify, or in the car. We would listen to those through Spotify. And now he can listen to them himself whenever he wants, which is great because he can't listen to those on the Tonybox. And I now have about 30 cartridges for him of his most beloved audiobooks. And I also 3D printed a little tray where they go in. It looks like one of those disc trays we had in the 80s and 90s where we put in our
Okay.
floppy disk.
Oh, you have to send me a picture of that one too. I'm curious.
Yeah. No, it's nothing special. It doesn't have the cover. It only has this little,
Ah,
yeah.
okay.
And he really enjoys it. He takes it with him on trips in a buggy, and yeah.
Okay. Cool, cool, cool. So,
Also, he figured out the backwards and forwards buttons himself,
mhm.
which is a good indication that the design is better than the Tonybox design for little kids because he had no exposure to any kind of device like that with forward and backward buttons
Mhm.
before.
How long does it take you to put new content on uh, a blank cartridge?
So
Just
first, I have to find the MP3s, and
mhm.
then I have made this,
Mhm.
which also is another tiny little rectangular device where I can put in a cartridge
Yeah.
and connect it to a USB-C to my PC, and then I just transfer the files. It's basically an SD card reader, a custom
Mhm.
one, which
Mhm.
has
Mhm.
which I can plug in the cartridges. So that takes all of 2 seconds, really. Once I have the MP3s, I just plug in an empty cartridge or an existing cartridge, which I want to override, plug in the USB-C cable and drag and drop the files. Constructing a cartridge itself means printing the cover, which is
Yep.
the rectangular thing I can screw
Mhm.
on, and getting the PCBs. But I ordered like 200 of these in one go,
So
which
hold on.
cost
So you have
like,
a PCB card, and then you kind of slide in the SD
no,
card into it, right?
yeah, exactly. You can see it on that one image. There's actually a micro SD card holder
Uh-huh.
soldered to the PCB,
Uh-huh.
and the holder has pins,
Do you have
which
to do that, or does it come? Do they come like that?
uh, these didn't come like that, but the next batch will come like that. Because I soldered like 30 of those by hand, and it
They
sucks.
exist, or did you also design those and now you get them?
No, I designed those as well.
Okay.
Those are trivial. If you look at that you see those traces going from the
Yeah.
pads to the SD.
Yeah.
That's basically all it is. It's just connect the pins from the SD card holder to the big fat pads at the bottom that go
Right.
into.
And when next time you order them, will this be already on it? This
Yes.
SD card? Okay, this is okay,
Yes,
got it.
I, because my manufacturer also supports assembly. So if I tell them,
Ah.
please print the PCB and then solder this fucking
Mhm.
annoying SD card holder onto it as well, so I don't have
Mhm.
to do it, I will
How
get that.
expensive is that? Like if you order a batch of, I don't know, what batch size is there? 100, 1,000?
I can go up to, I think, 50,000 or so. It's super cheap. Like I think
Uh-huh.
the
Wow.
the 100 cards I ordered were like 15 euros, just the
Mhm.
product, and then you have shipping.
Mhm.
100 is quite heavy. I think 2 kilograms, and shipping that from China to Austria
Mhm.
takes, I think, 30 euros or something like that. Overall, I calculated the cost of a single card, including the SD card that I also need to plug in, was something like, I think, €1.90 or so,
Mm.
including the 3D printer material, the PCB, the SD card, all of that stuff.
So this the card so this cover is also 3D printed. So you designed that too, that red
Yeah,
part. Okay.
yeah, exactly.
And you glue them together?
No, you can see screw holes, and just screw them together.
Screw them together. Okay.
Look at
Interesting.
this.
Hmm.
See?
Hmm.
Yeah.
Uh, how much unused um, memory space do you still have when you put an MP3 on it on average on that SD card?
So I get the tiniest, cheapest SD cards I can get, which are
Mm.
2 gigabytes in size. An audiobook is usually somewhere between 50 and 100 megabytes. So there's tons
Interesting.
of space left on the SD card.
Interesting. Interesting. How do you print out the covers that you glue on?
I just You can get labeling paper, which is
Mhm.
basically paper on the front and sticky in the back in A4 size. I You can buy them at Libro, which is an Austrian retailer for office materials, for like €2 or so for 50 A4 pieces. I
Mhm.
just put them in my printer tray, paper tray, and use a label designer to print multiple of these, cut them out, and then
Mhm.
stick them on.
Get a laser printer, I'm assuming.
Oh, it's a big fat Canon office printer, like a multi-thousand euro kind of
Yeah, but
office industrial printer
it's a
thing.
laser printer, right?
Oh yes,
Assuming.
definitely.
Okay.
Nothing fancy. Yeah.
Okay. Cool. 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 A color laser. All right. So now one topic. What do you think? Why do you think lithium-ion batteries should not be in devices made for children?
Because they're dangerous,
Yeah.
really dangerous. They are awesome because they have a high energy density, which means you can get a tiny battery with a lot of energy.
Uh-huh.
But that also means that if something goes wrong, there's a lot of energy in a tiny space, and that usually means something catches on fire or puffs out or explodes. And I don't want that in a kid's toy. Sadly, most electronics kids toys nowadays use lipo batteries or lithium ion batteries because they're cheap, and they're easily rechargeable with a little IC. Um, And yeah, I don't know. Like we have something called a tip toy, which is like a
Yeah,
pen
yeah.
with a little reader in the
Uh-huh.
front, and you can buy a book and you hold it on top of elements in the book, and it will play back some audio.
Yeah.
And that thing actually has a lipo battery in it.
Yeah, so
And
there's lithium ion and
yeah,
lipo, and lipo is the safe choice.
no, it's pretty much the same. It's just
Oh, it's the same.
a different kind of chemistry, but they're both equally dangerous. So I
Okay.
think lithium ion is more dangerous with water, and
Mhm.
lipo is a little less dangerous. Or still, I don't know. They're both dangerous. It's just
They're both
the only
dangerous.
takeaway. What do you mean?
Oh no, I'm bringing this up because that Yoto player it had a recall in the United States, I think a year ago, and I'm showing pictures here of uh, a Yoto Mini getting very warm. Like there's burn marks on the side, and you're wondering if those lithium ion batteries are in so many products. Um, they're not safe.
No, the problem
What's
is if you pinch them too hard, the internal layers may be crushed too much, and then you have like a chain reaction. A runaway reaction of energy getting released in form of heat.
okay? So they get
And
very hot.
yeah, super hot. And you can't easily put out the fire either. um, so the thing you handle that is you take it and put it in maybe um, some iron tray or metal tray and just throw it out the window. That's the best you can do and wait for it to stop burning.
What is a
Um,
safe energy alternative?
So a super safe alternative is NIMH batteries. I forgot what that's short for. They basically are indestructible, and the worst that can happen is that they gas out, which is not super toxic or anything. These are the batteries you would use in everyday electronics devices like remotes and stuff like that. Um, and um, The NIMH batteries are good because they're rechargeable. And then there's alkaline batteries, which are non-rechargeable. They are super safe. And that's basically all the options I can think of that would fit into devices like my little player or Game Boy.
So
Um,
if I get this right, then NIMH would be the safe choice, but they are not as energy dense
yeah,
and not as good.
yeah.
Or you have to charge them more often.
Uh, yeah, they're not as energy dense, so that means you need more of these to have the same amount of
Uh-huh.
energy
Okay.
than you would have with a lipo battery, for example. So you need more space, and they are not very flat. Even the AAA ones, they are, I think, a centimeter in diameter, or a little less, maybe. Whereas compared to the lipo battery of equal or higher density, it's much thinner.
Mhm.
And I think this one has twice the density than the batteries. The three batteries I now use have. Um, so there's a lot of design considerations when using a lipo. It just makes things a lot tinier. And I'm not sure if they actually charge faster. You can charge NIMH with 1C, which means you can put a lot of energy in it in a short amount of time. But I don't think most devices that also support charging the batteries inside of it would charge at that rate. Anyways, lipos are usually preferred for anything that's not in a child's hand. And you can make them pretty safe with protection mechanisms against short circuiting under voltage. That means depleting the battery too much, so the internal chemistry starts to fuck up and also become dangerous, or over voltage, which means charging it too much, so it also gets dangerous. Yeah, I just don't like it. And if I think about the tip toy my boy has, it has a lipo battery in it, and that one he smacks around a lot because for him it's
Yeah.
kind of like a pen. The pen
Yeah.
is not a device you have respect for. It's just something you use, right? And you might smack it around and smash it. So I don't want a lipo battery in there, but there is. Whereas in the Toniebox, there's actually, I think, NIMH batteries in there. So the Toniebox is super safe when it comes to that, which is great.
To learn. Um, so now that you've done it once. How long did it take you from start of the project to the first time you played it for your son?
Um, about 2 months,
2 months.
which means about 2 to 3 hours, 5 days of the week at night.
And if you do a second one, how long would that take you?
Well, 2 months means designing
Yeah,
it,
yeah, yeah. So now that you have
testing
all
it.
this in the bag.
Now that I have all of this in the bag, it would probably take me about 5 to 7 hours to assemble a new one if I have gotten all the PCBs and components I need sent to me.
Mhm. Okay.
It could
Um,
probably be faster if I didn't solder everything by hand, but had it assembled as well in China. But I like the soldering part because it's kind of like, I don't know, Zen.
so what feature requests have you gotten from your son or from the other kids in the neighborhood, or what features are you going to add next based on your own experience? Yeah, I'm assuming there's a V2 coming.
Yeah, the V2 is the one I hold in my hands now, which
Hmm.
doesn't use a LiPo battery anymore, but three dip AAA batteries. That was the V2. Honestly, it does what it's supposed to do. The only thing I need to still design is a cover for the speaker, like a little mesh maybe, and a better volume knob thingy that's a little bigger. But I pushed it off because I was more concerned about the LiPo battery thing, and I had to redesign the whole power
Yeah,
management of it, which took a while.
beautiful.
Um, but other than that, there is no V3 planned because this is exactly what it's supposed to do. And from my point of view, and apparently also from my boy's point of view, it's perfect. The only thing I might add at some point is a headphone jack.
Hmm.
Um, but that would also require a heavy redesign. And I'm not sure I'm going to do that because his use cases usually don't require headphones.
So just because you mentioned it earlier that um, chip you use inside supports Bluetooth.
Mm.
You could in the future connect it to a Bluetooth speaker.
Yeah, no. This is
Yeah.
a always offline device and it will stay like that.
Okay. Ah, okay. Always stay like that.
Yeah,
Okay,
because
cool.
that's also one part of the Toniebox I didn't quite like. I don't want my boys' listening habits to be recorded by some company.
I feel like this is one of the most important things we've not talked about so far. The privacy aspect of your product. It is really not connected to any network at all. It's all self-contained in
Yep,
the audio box.
yep.
Okay. So finally, let's talk about this. So again,
Mm.
I'm totally I love that space. And so recently I went to a clothing shop and it was a remodeling of the HQ. I think it's called Marine Layer. And they had in every changing room, they had one of these old school, really old ones, these old cassette players. And
Mm.
they had a selection of cassettes from 70s, 80s, rock music and music, popular music. And I had a very, very visceral reaction to that. I loved it. I needed to touch one of those cassettes. I pulled one out, I pulled three out. I went to the changing room, put on my shirt. Um, but all my attention was on that cassette player. It just looks cool. Pressing the buttons, the tactical element is really, really exciting. Like what you mentioned earlier, like pressing buttons on cassette players in your childhood.
Yeah,
That's
but
very
that's it.
exciting.
Like for the both of us, it's nostalgia to a lot of degree. Because for me, my cassette player was like my god.
Yeah, yeah. I mean, it is certainly nostalgia. How and there's two aspects now I want to add. My daughter and my son, they love the whole idea. They like to take this thing out of its cover, the cassette, and then hey, what is that? What do I do with that? Where do I put it? What do I press? Oh, there's music coming out of it. So there was a lot of excitement around that, and I liked it. My kids enjoyed it. And then something else set in. I'm like, okay, I'm reading the track list on this cassette. I want to listen to exactly that song. Getting to that song is almost impossible. You have to forward it, you have back. You don't know where you are on that cassette. Are you on side A, side B? Where are you? And that aspect of it, this whole thing doesn't work in for me in today's world anymore. Like
But
you
for me, it
expect
does.
certain
No,
things. Go ahead. Go ahead. Go ahead.
I
Please
don't.
let me know.
So I actually don't. Like instant gratification is, I think, one of the problems that we have. Like we're
Mhm.
constructing more and more of our world to be instantly gratifying. And there's benefits to that, especially in terms of productivity, because at work there's also gratification, right? If you do a job and you complete a task, that's kind of gratifying, hopefully, if your job doesn't suck. And making things more instant or taking
Yeah.
less time to get to a result in
Interesting.
that context makes sense to me, right? So I'm all for improving efficiency at work and productivity by shortening the time it takes you to do a specific task. But for leisure and education things, I think it makes sense to take out the speed. I having to listen to a whole B side or A side to find that one
Mm.
song is good. I would also posit that if you have to skip, if say you listen to the A side of a cassette for 10, 20 times, and you know
Yeah.
the order of songs and
Yeah.
you know about how long they
Yeah.
are, and you actually can pick out what song you're hearing after two
Uh-huh.
seconds of listening to it, I think that's a learning experience actually. And that's how I, when I was a kid and had my cassette player, would skip. Like I knew exactly where I was. I would press the forward button, wait for X amount of seconds because I knew that would kind of correlate with these amount of minutes in playback time, and then have it play and see, I'm still too early or I'm a little too late
So there's
because
an
this is now.
anticipation that you have in yourself, something, okay, I'm here and I know what I really am looking forward is coming in maybe 5, 6 minutes, and I have to listen through
Yeah, for
that.
example, that, or it
Uh-huh.
forces you to actually learn about the media, so to speak. It's saying that song, I need to know the song structure and the lyrics to know where I am in terms of time stamp within a song, right? If I only have skipping
Yeah.
forward and
Yeah.
backward.
Yeah.
And that kind of builds a different relationship between you and the media, I think, on a very task oriented level. I'm not saying this is like a completely new way of experiencing music and it's so much deeper. I'm not quite saying that, but it gives you a skill. And the skill is immediately knowing what song that is just based on 2 seconds of playback. And the funny part is, I experienced exactly that with my boy and the music box I built for him.
Okay.
While he can skip songs and chapters, right,
Uh-huh.
without the tediousness of a cassette player, um, if there are 35 chapters or files on the box, and he wants to go to song 20, he better know how many songs he has to skip before he hits the one
Mm-hmm.
song he
Mm-hmm.
actually wants. So turns out he also learned the structure of all the songs and knows exactly how they start. So he can actually press the
Mm-hmm.
button, skip
Mm-hmm.
forward, listen to like not even a second of the chapter, like just the first word or half of the first spoken word in the chapter, and knows exactly, oh, this is too early, and skips forward immediately. It's fucking amazing. Like it's kind of in between just typing in the song name you want and playing that, or selecting it with a touch screen from a list, right? Where you have a visual cue or the text. It's kind of between that instant gratification and the old tedious, oh, I have to skip forward and actually
Mm-hmm.
wait
Mm-hmm.
for quite a while. He still learns more, I think, than just picking a thing from a screen where he has a visual association with the one specific piece of media he wants to listen to.
Interesting. So do you, and you've talked about this before, wondering what are you thinking about this right now? We all listen to streaming services, right? Spotify, Apple Music, whatever it is. And we're drowning in content. Finding good content is hard. Maybe it's an age thing. Could you see yourself listening to music on your device? Like you actually kind of buying, like you bought CDs in the days, you selectively.
No, because it doesn't have a headphone jack, and I never listen to music on full blast. Actually, no, I could not, because for me, music has turn from a medium I actively and consciously consume to a medium that is playing back while I work on something. That sounds sad, but I've listened to so much music in my life actively that I'm kind of bored by music now. And I just need it for setting a mood, but not necessarily interacting with it intellectually or emotionally. So no, I don't see myself using this to listen to something because this player is meant for active, emotionally and intellectually engaged listening to a piece of media. And I'm no longer in the game of listening to music that way.
Okay. Well, on that note, thank you very much. That was
No,
exciting.
thanks for having me.
All righty.
Yeah.
Stop the recording.